Hello students. So today we are going to discuss the topic complex numbers. Okay. So the complex number we can consider as the universe of all the numbers, right? So the complex number is the universe of all the numbers and it is being divided further in two numbers, real numbers and imaginary numbers. Now, we are already familiar with real numbers. We already know all the natural numbers, all the rational numbers, all the irrational numbers, decimals, fractions, integers, whole numbers, all comes under the category of real numbers. And then we have one type of number, that is our imaginary number. Look, till date, we have been told that when we get something negative inside the square root, then it's something like not possible. We can't find the value of that. But here, when we get something inside the square root which is negative, then we call this as imaginary numbers. So look, the basic symbol for imaginary numbers is iota. And iota we represent by a small I, and this is nothing but a square root of -1. So a square root of -1 we call as iota. Now from here, if you square both the sides, what you will be getting? You will be getting I square equals to -1. Okay. Then let's try to find the value of I cube. Look, I cube will be I into I square, and the value of I square we can use from here. So this will give you I into -1. So this will be your minus of I, right? Similarly, we can find the value of I to the power 4, which will be I square into I square -1 into -1. This will be your +1. So look, here we have one important thing. Whenever we have the power of I in multiples of 4, let us say you can think of the power of I power 8. So this you can write as I power 4 whole square, and I power 4 is already 1. So 1 square will be 1. So from here we can make a note that whenever we have I power something in the format of 4n, okay, then we get how much? We get equals to always 1. So this is important thing. Now the question is, what will happen if we have some power on I which is not a multiple of 4? So here try to understand how we are going to deal with such situations. So for example, let us say we are taking the value of I to the power 75. So look, here the power exponent of I is 75. So always how we have to deal that? You have to divide 75 by 4. 4 into 1, 4, 3, 5, 4 into 8, 32, and then you have to find the remainder, which is here 3. Now what we can do here? 18 into 4, this is 72, and then plus 3, it's 75. So this 75 power of I we can break as I to the power 72 into I to the power 3. Now look, this I power 72, this is your 1. Why? Because the power here is multiple of 4. So for this you can take the value as 1 and 1 into I cube. Now I cube value is minus I, so 1 into minus I. So ultimately the value of I power 75 is going to be minus I. So from here we can make a rule that whenever we have some power on I, just divide that power by 4 and then whatever the remainder you are getting, okay, just that remainder power on I is going to left there. Nothing else will remain there. Only I to the power remainder will be there, right? So whenever we can make a note here that the value of I to the power m equals to I to the power r, where r is the remainder. When m is divided by 4. Okay. So now we can deal with any power of I. Now the question is, what will happen with the imaginary power? So look, in case of imaginary powers, you can deal in two ways. The first way would be like, let us say, for example, we have I to the power 75. Okay. So what you can do here, that, sorry, I to the power minus of 75, negative 75 is there. So look, whenever we have negative power, this we can write as 1 by I to the power 75. Okay. And now you can find the value of I to the power 75, which is, look, in the last example itself, we have solved this. So here the value of I to the power 75 is minus I. So that value we can directly put. So 1 by minus I. Now look, the general practice is that we are not leaving I in denominator. So how we can remove this I from denominator? So in that case, you just have to multiply with I in numerator as well as denominator. So whenever you have I in denominator, you have to multiply with I in numerator and denominator, so that, and later on I will explain that actually we have to multiply with the conjugate. Okay. So here you have to do what? 1 by I is there, and just multiply with I in numerator and denominator. Look, you have minus 1 into I and by I into I square. Now look, value of I square is minus 1. So minus I by minus 1, it gets cancelled. So you get the answer as I. Okay. The other way can be like this. Look, we have I to the power negative of 75. Just forget the negative sign, simply divide 75 with 4. Look, you will be getting 18 times. So 1, we have 3, 5, 8, 32, again 3 is the remainder. So look, the minus 75 power, we can further break as I to the power minus 72 into I to the power minus 3. Okay. Now look, I to the power minus 72. What will be the value of this? So look, if you are willing to write, this will be as 1 by I to the power 72, and I power 72 will be 1. So 1 by 1. So we can directly make a rule for negative also. When you have power on I in multiple of 4, whether the power is negative or positive, the value of that is going to be always how much? 1. So here you just have to deal with the value of I power minus 3. Okay. And this we can further write as 1 by I power 3, and I power 3 we already know, minus I means you will get this thing, and again you will multiply with I in numerator and denominator. Okay. So we can find the value of I with negative power also. And whenever I is in denominator, always keep in mind that you have to multiply with I in numerator and denominator. So likewise, we are having many important results, like when we have 4 consecutive powers on I, like I power 1, I power 2, I power 3, I power 4. That value is going to be 0. When you have I power 10 plus I power 11, I am talking about addition. I power 10 plus I power 11 plus I power 12 plus I power 13. That also is going to be 0, right? So that we will explain in the next session. Okay. So for today, for this session, that's all. So I'm closing the session for the day. Thank you.